Welcome to Jeremy's IT Lab. This is a complete course for the CCNP ENCOR, Enterprise Core exam. This course will cover all topics you need to know to pass the ENCOR exam. In this video, we will look at VTP, VLAN Trunking Protocol. Like the previous topic, DTP, we covered VTP in the CCNA course, and in this video, we'll review that information and also dig deeper, especially into VTP version 3. Here's what we'll cover in this video. First, I'll give an overview of VTP and its purpose. Then, I will introduce the 4 VTP modes: VTP authentication, do a comparison of the 3 VTP versions, look at the different kinds of messages sent by VTP, and finally look at VTP pruning. And watch until the end of the quiz for a bonus practice question from Boson Software's ExSim, the best practice exams for ENCOR. First, let's review some basics about VTP. VTP is a Cisco proprietary protocol that enables switches to synchronize their VLAN database with other switches in a VTP domain. A VTP domain is a group of connected switches, with the same VTP domain name configured. VTP automates the processes of adding VLANs, deleting VLANs, and naming and renaming VLANs on switches. If you make a change to a VTP server's VLAN database, it will advertise those changes and other switches will update their VLAN database. Note that VTP does not automate assigning access ports to VLANs, allowing VLANs on trunks, or any other interface configurations like that. It's all about synchronizing the VLAN database, which stores the VLANs that exist on the switch. Switches will synchronize their VLAN database with other switches in the same VTP domain. The default VTP domain is null, meaning no VTP domain. Note that the switch won't actually use VTP until it has a domain name. Even if you configure VLANs on the switch, it won't send VTP advertisements. The VTP domain can be configured with the VTP domain command in global config mode. Also, if a switch with VTP domain null receives a VTP advertisement, it will adopt the VTP domain name in the advertisement. I'll demonstrate that soon. The default VTP version is version 1, and it can be changed with the VTP version command. Similar to the domain name, if a switch running version 1 receives a VTP advertisement from a switch running version 2, the version 1 switch will move to version 2. Cisco documentation says that if a version 1 switch receives a version 3 advertisement, the version 1 device will switch to version 2. But I haven't been able to replicate that behavior. It might depend on the switch model and iOS version. Note that a switch will not automatically move to version 3. It must be manually configured. When using VTP, the revision number is used to keep track of the latest version of the VLAN database. Each time you make a change to the VLAN database, the revision number increases by 1. If a switch receives a VTP advertisement with a higher revision number, in the same domain of course, it will sync its VLAN database to match. And one final point. VTP messages are only sent over trunk links, not access links. You can disable VTP per port with no VTP in interface config mode. This stops the port from sending VTP advertisements, and if it receives an advertisement, it will ignore it. Let's take a look at the default state of VTP on these switches. Notice that they all run version 1 by default, although they are capable of running versions 1, 2, and 3. The domain name is blank. They aren't in a VTP domain, so although you can configure VLANs on these switches, they won't send VTP advertisements to each other. Note that the default VTP mode is server. We'll cover the modes soon. And let's look at these 3 lines here. Maximum VLAN supported locally is 1005. Why is that? VTP version 1 and version 2 only support normal range VLANs, so VLANs 1 through 1005. Version 3 supports normal, 1 through 1005, and extended range, 1006 through 4094. So that's why these switches running version 1 only support 1005 VLANs at the moment. Note that on some switches, you can only configure extended range VLANs in VTP version 3. But on other switches, You can configure extended range VLANs in VTP version 1 and version 2, but those VLANs are only saved locally. They are not propagated to other switches with VTP. For example, on these IOSV L2 switches I'm using for this demo, I can create extended range VLANs, even in VTP v1 or v2. On the switch I use in my home network, however, this is not possible. I can only create extended range VLANs if it's using VTP v3. Final point before moving on. Note that the default configuration revision number is 0. On switch 1, I configured the VTP domain name JITL and also configured VTP version 2. Without configuring switch 2 and switch 3, notice that they adopted the same domain name and version as switch 1. Also notice that the revision number is now 1. It was changing the VTP version that increased the revision number, not changing the domain name. Next, let's look at the different VTP modes. A switch can operate in one of 4 VTP modes: server, client, transparent, or off. You can configure the mode with the command VTP mode followed by the name of the mode. Server is the default mode. In server mode, the switch can create, delete, and rename VLANs. It can also modify the VTP version for the domain. If the domain is using VTP version 2, and you configure version 1 on a VTP server, the rest of the domain will move to version 1. VTP version 3 works differently. In VTP version 3, only the primary server can modify VLANs. There can only be one primary server in the domain. VTP v3 switches are secondary servers by default, and cannot modify VLANs. Basically, they function like VTP clients. The only difference is that they can be configured to become the primary server. To do so, use the VTP primary command from privileged exec mode. Note that this command is not done in global config mode. Anyway, I'll do some more comparisons of VTP versions 1, 2, and 3 later. Final point about servers. The switch will transmit and receive VTP advertisements and sync its VLAN database. Next up, client mode. In client mode, the switch cannot create, delete, and rename VLANs. It also cannot modify the VTP version for the domain. I configured switch 1 as a VTP client, and I was not able to create VLAN 2. However, if the switch can locally create extended range VLANs in version 1 and version 2, it can do so in client mode. Remember I said a couple slides back that some switches can locally create extended range VLANs in version 1 and version 2, but the switch won't propagate the VLANs using VTP. This IOSV L2 switch is an example. I was able to create VLAN 1006, an extended range VLAN, on the switch, even though it's in VTP client mode. Note that this will not work in VTP v3. VTP v3 clients cannot create VLANs in the normal or extended ranges. Final point. Just like VTP servers, a VTP client will transmit and receive advertisements and sync its VLAN database. Next up, transparent mode. A transparent mode switch can locally create, delete, and modify VLANs. However, it will not participate in VTP. By that I mean that it will not sync its VLAN database with other switches. However, it will forward VTP advertisements it receives out of its trunk ports. There's one requirement though. The VTP domain in the advertisement must be the same as the switch's domain, unless the transparent switch's domain is null. In that case, it can forward VTP advertisements without a matching domain name. Okay, the final VTP mode is off, which was added in VTP v3. In this mode, VTP is disabled. The switch can locally create, delete, and modify VLANs, but it will not participate in VTP. It won't sync its VLAN database with others, and it also won't forward VTP advertisements. It doesn't participate in VTP at all. Note that if the switch supports VTP v3, you can configure off mode even when using v1 or v2. At least that's the case on the switches I tested. So I configured switch 2 in VTP transparent mode. Notice the output of show VTP status has changed. Compare the 3 switches' revision numbers. Switch 1 and switch 3 have revision number 1, but switch 2's revision number is 0. That's because a switch in transparent mode will always have revision number 0. In fact, changing a switch to transparent mode and then back to server or client mode is one way of resetting the revision number if you need to. Next, I created VLAN 2 on switch 3. Now, switch 1 and switch 3 both have 6 VLANs, but switch 2 only has 5. After creating the VLAN, switch 3 sent a VTP advertisement out of G00. Switch 2 forwarded that advertisement to switch 1, but switch 2 itself didn't sync its VLAN database. And note that switch 1 and switch 3 now have revision number 2, while switch 2 is still at 0. I then configured VTP domain JITL, all uppercase, on switch 2. Now, switch 2 has a different domain name than switch 1 and switch 3, because the VTP domain name is case sensitive. So I created VLAN 3 on switch 3. And now, notice that switch 3 has 7 VLANs and a revision number of 3, whereas switch 1 still has 6 VLANs and revision number 2. So switch 2 did not forward switch 3's advertisement to switch 1, because it's in a different VTP domain. Note that afterward, I changed the domain on switch 2 back to lowercase jitl for the rest of the demonstration, so it will forward VTP messages between switch 1 and switch 3. Next up, VTP authentication. You can configure a VTP password for authentication, although it is optional. The command is VTP password. A VTP switch will only sync its VLAN database if the VTP password in the advertisement is correct. However, a transparent switch will forward VTP advertisements even if the password is different. Let's see how the password works. First, on switch 1, I checked the VTP revision number, which is 3. Then I used show VTP password. This will display the VTP password, or in this case, say that there is no VTP password configured. So I configured a password on switch 1. Then, on switch 3, I checked the revision number, which is the same as switch 1. I then created VLAN 4 on switch 3, and the revision number increased to 4. However, on switch 1, the revision number is still 3. Switch 2 did forward switch 3's advertisement to switch 1, but because the advertisement didn't specify a password, switch 1 ignored it. So I then configured the same password on switch 3, and after it sent an advertisement, switch 1 updated its VLAN database to match switch 3. The revision number is now 4 on both switches. In VTP version 3, the password can be encrypted. You can use the command VTP password, the password, and then hidden to configure and encrypt the password. There is also VTP password secret. You can use this command to configure an already encrypted password. Let's see how that works. After moving both switches to version 3, on switch 1 I configured VTP password Jeremy's IT Lab hidden, and then viewed the encrypted password with show VTP password. Then I copied that encrypted password and configured it on switch 3 with VTP password, the encrypted password, and then secret. That's the difference between the hidden and secret keywords. Use hidden to encrypt a password, and use secret to configure a password that has already been encrypted. Now let's compare the VTP versions. VTP versions 1 and 2 are very similar. Version 2 adds token ring support and a few other things, but in general there's no reason to use version 2 over version 1. Token ring is an old technology that isn't used anymore. Do a Google search for this VTP configuration guide from Cisco if you're curious about more differences between V1 and V2. VTP version 3, on the other hand, added some significant new features. I'll summarize them here. One is enhanced authentication. As we just covered, version 3 added the hidden and secret keywords to the VTP password command. And version 3 also added extended range VLAN support. We covered this before too. VTP version 3 can propagate extended range VLANs. And on some switches, extended range VLANs can't even be created if the switch isn't using VTP v3. Version 3 also added support for private VLANs. Private VLANs aren't an ENCOR topic. They are a method of further segmenting VLANs, and you can learn about them in the CCNP security track. Before VTP v3, only switches in transparent mode could use private VLANs. Version 3 also added multiple spanning tree protocol support. VTP v3 can be used to propagate MST database information. MST is an ENCOR topic, and we'll cover it later in the course. And here's the most relevant change you should know about for ENCOR: primary and secondary servers, which I mentioned before, but I'll summarize it here. Only one switch in the domain, the primary server, can configure VLANs and propagate them with VTP. Use VTP primary in privileged exec mode to configure the primary server of the domain. The primary status is lost if the switch reloads, or other VTP domain parameters such as the version change, or even if a VTP password is configured. That will cause the primary server to become secondary. If you use the VTP primary command to make a second switch, the primary server, the first one reverts to secondary. So what's the reason for having only one switch that can configure VLANs? It solves the problem of a new switch connected to the domain accidentally overwriting the VLAN database. I mentioned this problem about VTP in the CCNA course. It's a common worry, and a reason that it's often recommended to not use VTP. But if you use VTP v3, there is no need to worry about it. VTP can be a great tool to ensure VLAN database consistency, especially in a network with a lot of switches. Before moving on, let's see how configuring the VTP primary server works. I made all three switches VTP version 3 servers. Notice that on switch 3, I am unable to configure a new VLAN. It says VTP VLAN configuration not allowed when device is not the primary server for VLAN database. So I exited to privileged exec mode and then used VTP primary to make switch 3 the primary server. Note that if the VTP password is configured with the hidden or secret keywords, you must enter the password for the switch to become the primary server. This doesn't apply if the password is in plain text. It says no conflicting VTP3 devices found, which is expected, and then asks for confirmation that I want to make this the primary. I hit enter, and then check Show VTP Status, and note that the operating mode is now primary server on switch 3. Then I used the VTP primary command on switch 2 and made it the primary server. Note that it says no conflicting devices this time too. This doesn't mean that there is no other VTP primary server at the moment. As you know, switch 3 is the current primary server. In the lab video, I'll demonstrate a conflict and what can cause it. Anyway, I hit confirm to make switch 2 the primary server. And now, switch 3 is no longer primary. It is just a server, also known as a secondary server. You can use the Show VTP Devices command to view switches in the VTP domain. Note that this command works in VTP version 3 only. As I've highlighted in pink, switch 2's entry has the same MAC address under primary server and device ID, and there is an equal sign between them. That means that switch 2 is the primary server in the domain. Next, let's look at the different VTP message types. You don't need to know the contents in detail, but I'll give a quick summary. VTP uses 3 different message types, all sent to multicast MAC 0100, 0CCC, CCCC. I mentioned this one in the DTP video. It's shared by multiple protocols such as CDP, VTP, DTP, etc. VTP messages are sent in VLAN 1, untagged if the native VLAN is 1, or tagged in VLAN 1 if not. The first kind of message is summary advertisement. These messages inform other switches of the VTP domain name and revision number. They are sent once every 5 minutes, and also when there is a change to the VLAN database. Here's a summary advertisement message, indicated with code 1. There's not much information in these messages, beyond the domain name and revision number. The next message type is subset advertisement. These messages contain VLAN information, the VLAN database. And depending on the number of VLANs, multiple subset advertisements might be needed to share the whole database. These messages are sent when there is a change to the VLAN database, along with the summary advertisement mentioned above. Here's a subset advertisement message, indicated with code 2. Notice there is a list of VLAN information fields in the message. Each of these contains information about an individual VLAN. There is another situation in which both summary and subset advertisement messages are sent, and that is in response to the next type of message, advertisement request. These messages are sent in the following situations: when the switch resets, when the VTP domain name changes, and when the switch receives a summary advertisement with a higher revision number. The switch sees the higher revision number and then sends a request to get the latest version of the VLAN database. When a switch receives an advertisement request, it will reply with a summary advertisement and one or more subset advertisements, depending on the size of the VLAN database. Okay, that's all we'll cover about VTP message types. The final topic for this video is VTP pruning. VTP pruning automatically removes VLANs from trunk ports to reduce the size of broadcast domains. Although VTP ensures that each switch in the domain has a matching VLAN database, you don't necessarily need traffic in all VLANs going to all switches. VTP pruning prevents frames from being flooded in a direction where there are no hosts to receive the frame. It is disabled by default, but can be enabled with the VTP pruning command in global config mode. Note that you only need to enable it on one server in the domain. It will propagate the setting to the other switches. Manual pruning is the process of manually configuring the allowed VLANs on a trunk. I demonstrated this in the VLAN video by using the switch port trunk allowed VLAN command. Well, if you're using VTP in your network, VTP pruning can do that automatically for you. So let's see how it works. In this network, let's say a host in VLAN 10 connected to switch 1 sends a broadcast frame. Switch 1 floods it out of G00 and to any other hosts in VLAN 10 connected to it. Switch 2 floods the frame as well, and so does switch 3. What about switch 4? It just drops the frame. It doesn't have any hosts in VLAN 10 connected to it, so there was no need for switch 3 to flood the frame toward switch 4. So VLAN 10 should be pruned from switch 3 G00. No hosts in VLAN 10 are connected to switch 4, so frames in VLAN 10 don't need to be flooded in that direction. On switch 3, I used show interfaces trunk, and take a look at the section I've highlighted. VLANs in spanning tree forwarding state and not pruned. That is referring to VTP pruning. So currently switch 3 will flood frames in VLAN 10 out of G00. Let's configure VTP pruning to change that. On switch 1, I configured VTP pruning. However, I could have configured it on any of these switches. They are all VTP servers. Notice how the output has changed. VLAN 10 has been pruned from switch 3 G00. It won't flood frames in VLAN 10 out of that port. Now, there are no hosts in VLAN 1 either, but it hasn't been pruned. Why is that? VLAN 1 and extended range VLANs cannot be pruned by VTP, even in VTP version 3. Keep that in mind. If you want to remove VLAN 1 or any extended range VLANs from a trunk port, you have to do it manually. Okay, here's a summary of the VTP-related commands we looked at in this video. This is not an exhaustive list, but you probably don't need to know more than this for the ENCOR exam. If you don't remember any of these commands, go back in the video to review. And here's what we covered. First, I gave an overview of VTP and its purpose. Then, we looked at various aspects of VTP, including VTP modes, authentication, the different versions, VTP messages, and VTP pruning. Now let's do a quiz to test your understanding. And make sure to watch until the end of the quiz for a bonus practice question from Boson Software's ExSim for ENCOR. Okay, here's quiz question 1. Examine the following output. Switch 1 is a VTP client that syncs its VLAN database to a VTP server. Switch 1 does not flood frames in VLAN 20 out of its G00 port. What is the reason for this? Pause the video now to think about the answer. Okay, the answer is A, manual pruning. You can know this by looking here. VLAN 20 isn't allowed on G00, meaning that it was manually pruned with the switch port trunk allowed VLAN command. If a VLAN is pruned by VTP, it will appear here and in the section below, but not in the bottom section that says VLANs in spanning tree forwarding state and not pruned. So A is correct and B is incorrect. C is incorrect because VLAN 20 does exist on switch 1. We can see that it's active on the G01 interface. And D is incorrect because we don't know if there are hosts in VLAN 20 connected to switch 1 or not, but it's not relevant to the question anyway. Okay, let's go to question 2. Which of the following VTP-v3 switches can create, delete, and name or rename VLANs? Select all correct answers. Pause the video now to think about the answers. Okay, the answers are A, D, and E. The primary server is the only switch that can create VLANs and propagate them through the VTP domain. However, transparent and off switches can also create, delete, and rename VLANs, although they don't participate in the VTP domain. Okay, let's go to question 3. Examine the network topology. You configure switch 2 and then switch 1 in that order, with the configurations below. So on switch 2 you configure VTP mode transparent, and then on switch 1, VTP domain JITL and VTP version 2. Which of the following statements are true? Select 2. Pause the video now to think about the answers. Okay, the answers are A and D. Switch 2 will be in VTP domain null using VTP version 1. Because you first configure it in transparent mode, it won't sync to switch 1's advertisements, but it will forward the advertisements to switch 3, which will then use domain JITL and version 2. Okay, let's go to question 4. You want to configure the VTP password CCNP ENCOR and encrypt it. Which command should you use? Pause the video now to think about the answer. Okay, the answer is C. VTP password CCNP ENCOR hidden. The hidden keyword is used to configure and encrypt a password, whereas the secret keyword, as in option A, is used to configure an already encrypted password. B and D are not valid commands. Okay, let's go to question 5. Which VTP message type is used to share information about the VLANs in the VLAN database? Pause the video now to think about the answer. Okay, the answer is D, subset advertisement. A subset advertisement like this one will include VLAN information fields, each one giving information about a particular VLAN, such as its VLAN number and name. A, advertisement request, is a message type used to request a VTP advertisement. B, summary advertisement, is used to give basic information like the VTP domain name and revision number, without sending the whole VLAN database. C, database advertisement, is not a valid VTP message type. Okay, that's all for the quiz. I hope this lesson was helpful. Now let's move on to a bonus practice question from Boson Software's ExSim for ENCOR. Here's today's Boson ExSim practice question. You are about to connect 5 switches, as shown in the following topology diagram. So there are 5 switches, with switches A, B, C, and D connected via switch E. This is important because we will have to make sure that switch E is able to forward VTP advertisements between the other switches. Then it says, trunking is enabled for each port that will connect to another switch. So that means they are able to send VTP advertisements. You issue the show VTP status command on each switch and receive the following output. Okay, here is the output for each switch. Let's check the question at the bottom. How many VLANs will exist on each switch after you connect the 5 switches? Okay, before checking the options, let's take a look at each switch's output, starting with switch A. The domain is Boson, and it's a VTP server. Then switch B is also in the Boson domain, and it's a client. Let's compare switch A and switch B's revision numbers. Switch B's is higher, 17, compared to switch A's, which is 3. Remember that even though switch B is a client, and therefore you can't edit the VLAN database on switch B, it will still send advertisements, and if switch A receives those advertisements, it will sync its database. Also worth noting is that both switches A and B are using VTP version 2. That also has to match between them, or they won't sync. Next, let's look at switch C. Its domain name is Boson with a lowercase b. So this is not the same domain as switch A and B. The VTP domain name is case sensitive, so it won't sync its database with switch A and switch B. Next, let's check switch D. Its domain is Boson with an uppercase B, so the same as switch A and switch B. It's also using VTP version 2. But switch D's mode is transparent, so it won't sync its VLAN database. Finally, switch E. Its domain is Boson with a capital B also. It's using VTP version 2, and it's transparent, so it won't sync its VLAN database. Okay, let's look at the topology once more. Switches A, B, D, and E are in the uppercase B Boson domain, and C is alone in the lowercase b Boson domain. So C won't change its number of VLANs. It won't sync to other switches. D and E won't sync their VLAN databases either, because they are in transparent mode. However, because E is in the same domain as A and B, and also using the same VTP version, it will forward switch A and switch B's VTP messages. So A will sync its database to match switch B's database, as I said before. So to review before we check the answers, C, D, and E won't change their VLAN databases, and A will sync its database to match B. So let's check the output again. Switch B has 3 VLANs, so that means A will have 3 too. So 3 VLANs for switch A and B. Then switch C has 6 VLANs, and it will have that same number after connecting the switches because it's in a different domain. Switch D has 7 VLANs, and it won't sync its database because it's in transparent mode. And finally, switch E has 14 VLANs, and also won't sync its database. So after connecting all of the switches together, switch A, B, C, D, and E should have 3, 3, 6, 7, and 14 VLANs respectively. Let's check the options. A is wrong, B is wrong, C says switches A, B, and C will have 3 VLANs, which is wrong. C will have 6 VLANs. Option D is wrong. Option E says switches A and B will have 3 VLANs, C will have 6 VLANs, D will have 7 VLANs, and E will have 14 VLANs. Okay, E should be the correct answer. And option F says A will have 12 VLANs, which is not correct. So I'll click on Show Answer, and as you can see, E is the correct answer. So I'll scroll through Boson's explanation. I recommend pausing the video to read it. The explanations are one of the great things about ExSim. So that was a quick look at Boson Software's ExSim for ENCOR. These are the best practice exams for ENCOR, and are an essential tool to get ready for the exam, which is why I recommend them and use them myself. Before finishing this video, let me thank my JCNP level channel members. To become a member, please click the Join button under the video. Thanks to Jonathan Makara, Velva Jacob, Funny Dart, Nasir Chowdhury, Devin Suku, Gustavo B.R., Marcel Lord, Pavel M., Mr. Erlison, Dragos Hirnea, Zakib Shah, Mayor Salman, Mazen Anderson, Vitaus194, Gina Lindley, Mark Jackson, Bold 1C1U, Michael Carroll, Gerald Guillaume, Gabriel Braga, Hector Hernandez, Maratuba, Roji Kuriakos, Arpad Konives, 5 Feet, Owa, Daniel Brown, Tricky Mickey 123456, Scott Thompson, Jose Alvarez, Hussein Yavuz, Samuel Tavares, Roger Bratseth, Mustafa Ersoy, Nasser Zahar, Brian Grant, Kyle, Georgi Gemejev, Arlen Plagaria, Dear Diso, Adelson Pereira, Farad69, Madmark 50484, Sean Powell, Alexandru Stratan, Hiago Bicalho, Abdo Zizo, Piotr Kaimov, DMJ2, Kurt Nell, Preeti Dongave, Abubakar Berry, Omid Farakesh, Steve Cox, Jasper Yim, Wilmer Romero, Enigma G, Laurent Lam, Emmanuel Nupsido, King Doka, Pedro Hartman, Ivano Capuano, Jefferson Steelflex, Sinan Sarisinar, Karamjit Singh, Alejandro Okana, and Burrell Campbell. Sorry if I pronounced your name incorrectly, but thank you so much for your support. Thanks to you and my other supporters, I am able to make these videos and release them for free on YouTube, so I really appreciate the support. Another great way to support the channel is to like the video, leave a comment, subscribe, and most importantly, share this video with others. So if this video was helpful, I'd appreciate it if you did any of those. Thanks for watching.